Now that you have some notes over type 2 projectiles, I'd like to go over this practice problem number 4 from page 152 in your textbook. A player kicks a football from ground level with an initial velocity of 27.0 meters per second, 30 degrees above the horizontal, as shown in figure 6.4. Find each of the following. Assume that air resistance is negligible. When they say assume air resistance is negligible, they're saying that there's no force acting on the football in the x direction, so we can treat the x direction, the horizontal direction, as constant velocity. So we need to find the ball's hang time, the ball's maximum height, and the ball's range. When I do these problems, sometimes it's really helpful to actually set up a table with 3 tiers, or 3 columns, instead of just the 2 that I've been doing. What that's going to look like is this. I've got my x, the range. I've got my y to the apex, so the middle. And then I've got my y total. Because when I'm talking about the ball's max height, we're talking about the journey from the beginning to the apex. And then when we're talking about the ball's range, we're talking about from the beginning all the way to the end. So that's talking about 2 different time intervals, half the time and then the total time. So that's why I like to have my table set up with 3 columns instead. So in the x direction, we're still just going to have delta x and my velocity in the x direction and my change in time, and this is going to be the total time. This is referring to the time that it takes for the ball to go from where it starts to where it hits the ground again. So from ground to ground, that total amount of time. Now for y apex, that means that we're talking about the change in y up to the apex. So that's going to be the max height. Then we have acceleration still. We have our change in time, and then this is just the time up. So this is just up to the apex. So time up, remember, is equal to 1/2 the total time. And then we have our initial velocity in the y direction. And then we have our final velocity. We have our velocity in the y direction at the apex. And we know our velocity at the apex is 0 meters per second. And then in our last column, we have y total. So this is delta y total. And since the object is going up and then coming back down to the same height, that total change in position is 0 meters. Then I have acceleration, change in time, and this is total again. And then I have my initial velocity in the y direction, and then I have my final velocity in the y direction. And remember that that is equal to opposite negative velocity, initial velocity in the y direction. Those things are opposite. So let's use this table to fill in the rest of the information that we know. All right, we know that the initial velocity is 27 meters per second. At an angle of 30 degrees. Okay, now that initial velocity, v0, is not given anywhere in my table. What is given in my table is my vertical velocity, viy, and my horizontal velocity, vx. So remember that viy is given to me by v naught times sine of theta. And here, v naught is 27 meters per second, and theta is 30 degrees. And Vx is going to be 27 meters per second times the cosine of 30 degrees. So that's something that I can write in here. 27 will not go anywhere on this table, but I can put in 27 meters per second times the cosine of 30, and I can put in here 27 times sine of 30, and the same thing right here, 27 meters per second times sine of 30. Okay. And then that tells me that my final velocity in the y direction would just be negative 27 times sine of 30. All right, I can also write down some other just generic given information, like my acceleration, negative 9.8 meters per second squared. Do you guys see how much information we actually have to get organized? And this is why these kinds of problems get so much more complicated. Okay, now that I have all of this information, it's time to try to figure out the ball's hang time. Now when we say that we want to know the ball's hang time, are we talking about the total time all the way from ground to ground, or are we talking about half of the time up, or the time down even? The hang time is referring to this whole thing. So if you're going to calculate hang time, you need to be looking at this part or this part. Now, based on what information I have in the table, should I be starting with the x information or the y total information? Well, I have a lot more given to me in the y total on the y total side. I know that my change in y is 0. I know acceleration is negative 9.8. I know my initial velocity, and I know my final velocity. So I can definitely find my change in time over here. On my x side, all I have is my velocity in the x direction. I don't have the range or the time here, so I definitely can't find time. All right, let me go ahead and shrink this part down so I have some space to work in. Okay, there we go. My change in time, I need to use my y total information in that column. I need an equation. I really want the easiest possible equation that I can use for my change in time here. And I know from my list of equations, let me write those equations up here real quick. Looking at those equations, which one would be the simplest? Well, I know I can't use number 3 because it doesn't have time in it. Number 2 isn't bad, but if I actually go and fill in all of my information for time, I am going to have to use the quadratic formula. I might as well just use number 1. There's something really fancy that I can do here with equation number 1. Just because this is a type 2 projectile, and because I know that my final velocity in the y direction is equal to my initial velocity in the y direction except negative. So let me plug in some things and solve this actually algebraically. This is a place where solving things algebraically before starting to plug in the numbers is finally going to be really beneficial. Okay, let's say that we've got v final in the y direction equal to acceleration times my total time plus my velocity initial in the y direction. Well, I'm going to go ahead and plug in for my y final. I'm going to substitute this piece of information for my final y velocity. I'm going to change it so that it's negative initial y velocity. So if I do that, that's going to be negative VIY is equal to acceleration times my change in time plus my initial velocity in the y direction. All right, now I need to solve for time. The first thing that I need to do is subtract initial velocity in the y direction over. What's that going to equal now? Well, I've got negative VIY minus VIY. So think if that was just negative x minus x. Well, that'd be negative 2x, right? So this is going to be negative 2 VIY. And that's equal to acceleration times change in time. And now all I need to do is divide by acceleration on both sides. And I end up with this really, really slick equation that delta t is equal to negative 2 times my initial velocity in the y direction divided by my acceleration. And that actually, this is a very, very helpful equation that I highly recommend you write down on your note card when you're working on these types of problems, because you can use this equation to solve for the total time any time you are doing a type 2 projectile problem. It will always work. If you want to know more about why that will work, you can definitely come and talk to me and ask more questions. So now to solve for time, all I've got to do is plug in my information into this equation. So that means that change in time is equal to negative 2 times my initial velocity in the y direction, which is 27 meters per second, times sine of 30 divided by negative 9.8 meters per second squared. And when I calculate that, I get what? Well, you should get 2.755, so about 2.76 seconds. That is the hang time, the total hang time of this ball. Next, they're asking me for the ball's maximum height. When I talk about the ball's maximum height, what they're referring to is the apex. So we're going to be using this piece of information here. So if I want to find that apex, looking at my equations 1, 2, and 3, I could use 2 or 3. I know the time now. I know the total time, but I know that time up to the apex is 1/2 of that. So I would just need to divide by 2 in order to get that time. So I could use this equation here, number 2, and I can also use number 3. Because I know that my final velocity is 0 at the apex. I know my initial velocity is 27 times sine of 30, and I know my acceleration. So it's just a matter of which equation you want to use the most. I'd prefer to just use v final squared is equal to v initial squared plus 2a delta d, because I can very easily solve for delta d. That's going to be v final squared minus v initial squared divided by 2a, and I know that my v final is going to be 0. So I get delta d is equal to negative 27 times the cosine of 30 squared divided by 2 times negative 9.8. And then my my change in position is equal to 9.298, or about 9.30 meters. So there's part B. And finally, part C, the ball's range, that's talking about its horizontal change in position. So I'm definitely going to want to use this first column, the X column. I now know that my change in time is that 2.76 seconds that I calculated for part A. So all I have to do is my change in X, equation number 4, which is delta D is equal to velocity times change in time. So my change in X, my change in position in the X direction, is equal to V times delta T. Delta X is equal to 27 meters per second times the cosine of 30 times 2.76 seconds. And that change in horizontal position is 64.5 meters. There you go.